Okay, let's see how many people we have here. 2, 4, 6, 8, 10, 11. There are 15 enrolled in this class. 11 of you are here. 1/3 of the class didn't turn in the project, which means that at this point, 1/3 of the class is going to fail. I imagine some of you who did turn in the project didn't have it completely working. So this gave me pause a little bit because Project 1 is easy compared to Project 2, and so if you're really struggling with Project 1, I think what I will at the moment chalk it up to is not realizing the complexity of doing this. So I'm all into second chances. And what I've created here in the course shell is I've opened up the submission link again, added 7 days to it. Is it not open? Well, I'll open it then and put 7 days. Oh, I think there are actually two dates I need to change on that, and I only changed one, so that's why you're not seeing it. I guess while I'm talking, I will do that, or I will forget it. So it's this one. All right, now it should be visible. Okay, so the only thing I've added here is this link right here, this p1enhance.html, and here's my thinking. There are some of you who certainly have finished, right? And I don't want you to simply be spinning your wheels. So there are enhancements that I think are healthy to have in the project regardless. And you probably have some of these, but not all of these. I very much doubt you all have all of these enhancements. And for the most part, it's error checking. But let me walk through them real quick. Allowing the text file map to have inconsistent line lengths, and the symptom of that is, I talked about it briefly, if you're, oops, well, what are these, asterisks? Oops. Alright, instant gold mine. So if I, whoops, now what the hell did I just do? So here's an example of where what I've been disciplined about doing in the maps I provided is I've been disciplined about padding these kinds of lines with spaces, right? So they all line up. Then you don't have to think about it. You just read in all the lines and you take the length of any one of these lines, and that's how many columns it has. Well, I want you to be able to handle maps that are kind of like this. So if you're just making the number of columns the line length of any of these lines, then you just simply have to measure the line length of each, and whichever has the maximum line length is the number of columns, right? And then at which point you do it, there are different places you can do it. You could either, if you're reading this in to a vector of lines, you could actually go back through and pad these with spaces. I think what I did is I did it at the point, I did read these in as a vector of strings, and then I merely did the conversion, and then at the end of the conversion for a particular string in the vector, I just checked its length against the expected number of columns, and if they weren't the same, I just took the difference and added that many zeros. to ensure that you're right, because it's at the end of the day, it's your array of bytes in the shared memory that has to have an equal number of columns, rows times columns. So however you do it, that's what number one is getting at, that you're able to handle that and the integrity of your memory stays there. I kind of liked this implementation that I did. I've been recoding all these, and I kind of like this idea, so I'd like you to follow it. You need to check the argument count. If it's anything other than 1 or 2, you need to bail out. And if it is provided, if argv sub 1 is provided, which means argc is 2, the argument count is 2, the second one obviously, this one being the name of the map, you immediately assume that person wants to be the first player playing the game. So you go ahead and you open, what were we doing? Opening the semaphore with the O-create, O-EXCL exclusionary bits set, and right, that's going to fail if the semaphore already exists. If that happens, then you need to complain and say another player's already playing. Don't provide a map, another player's already playing, something like that. And then the converse is true. If you don't provide an argument, you open the semaphore without creating it with the EXCL bit, assuming that someone else is already playing. And if there is no semaphore, you get an error on that opening the semaphore, then you error out and say nobody's playing, you need to provide the name of a map, right? Now once you do that, you can use 2 totally different functions for initialization. And the first one, where the map is provided, I think what many of you have is you just have an if statement, kind of an if-else. Well, based on whether or not argument count is 1 or 2, you can call totally separate functions and keep that code completely separate to be able to, in this case, create the semaphore, lock it, create the shared memory, f-truncate it, you read in the map, you put all the bits in there, you drop all the gold on there, and you provide the player ID, which will be G_PLR0. This one, you open the semaphore, you lock it, you connect to shared memory, grab the rows and columns, do the mmap, and then you figure out which player bit's available. And then you could make common code the actual dropping of the player. So in this, the last thing you do is you know that you're going to be G_PLR0, so you have some sort of variable for what that process's player is that you set. I call mine player ID. I set player ID to G_PLR0. Here, you're checking that player's byte in the structure, finding a free bit. Once you find a free bit, you set the player ID to that variable. And then both of these functions fall out to common code, and the first thing the common code can do is find a place to put the player using player ID, right? That code can be identical. And then all the code, the switch statement and the while loop, what you play as long as they don't enter queue, all that's common code, right? So 2 separate functions for the initialization, common code for everything else. And so to the extent you've got this big, huge, long single function, this will help you divide that up, make it a bit more readable and debuggable. If the map file can't be opened, so this would tie to this one. If you can't open that file, then complain and close and remove the semaphore. So the idea here is that with this one, the first thing you're going to do is try and create that semaphore, because the assumption is you're the first player. If that works, then you lock the semaphore, and then after you lock it, you're going to go ahead and open up the text file for the map. And if they put in a typo and the map doesn't exist in the file system, then you just need to complain, and here's the key, you got to clean up, close the semaphore and remove it. Okay? And then exit out. The map constructor. So again, this is the class that I provided and does all the visualization. You call draw map and get key and post notice on this class. If I think many of you, and you've certainly seen me do it, when I started up in my window, physical window isn't large enough, it kind of flashes, screen not large enough, a couple seconds, and then it just quits out. Okay, what that's being done in this map class, and if that happens and it's not large enough, it throws an exception. And all this is in the constructor. The constructor is what tries to paint that initial map on the screen. So what you need to do is you need to catch that exception and end the program gracefully. And I've basically written the code you'd require. The variable names you have may be different. One of the things I think I'm going to start getting pretty anal about is that you don't have memory leaks. And the best way to avoid memory leaks is to use smart pointers. So if you haven't used smart pointers, here's your big chance. And I provided the code for all you need with smart pointers for this project. Yes?
Smart pointers aren't available in C though.
We're not programming in C. We're programming in C++. I hope. If you're totally unfamiliar with these pointers, the two most common you're going to find are unique pointer and shared pointer, and their names imply their usage. Shared pointer is got many variables pointing to the same memory. Unique pointer doesn't. What they do to prevent memory leaks is, so this is in essence a pointer to a map object. And then rather than here, if this was a bare pointer like we're accustomed to using, here you would say map pointer equals new map, and then you'd have the constructor arguments. Here you just, rather than saying new map, you basically call this function to make a unique matching. This type, it would be make shared if you're using a shared pointer. And this is the thing we're making. These are the arguments to the map constructor, the initial memory, the rows, the columns. So this will actually call new for you. And what prevents the memory leaks is this is I don't know what you want to call it, a normal variable like a string, right? Like you string str. And the thing about string str is when you hit the end of the enclosing block, the destructor for the string class runs. So this ensures that when map pointer goes out of scope, it's going to run maps destructor. It's basically going to delete the memory, which will cause the destructor to run. And what makes it great is you don't have to care about that. It'll do it automatically, right? Everything up to this point is you've had to manage your own memory. All your allocations have had to have releases. And based on the code I've been seeing at the 500 level, no one seems to teach that. Everyone teaches the new. No one teaches the deletes because a lot of memory. If I had a nickel every time I saw a memory leak. So this is your big chance to rectify that problem.
So is it improper to call delete on a unique pointer just because it's redundant?
It will not work because this is not a raw pointer. This is an object in the same sense that a string is an object, right? It's in essence it's a wrapper around the pointer, and but it does a pretty good job. So when you access it, let me see. Well, you access it the same way, right? If you had a pointer to a map object, you just use an arrow to call the member functions. It's the same thing. So it hides it pretty well, but the creation of it is what's a little bit more turgid than just simply using a raw pointer.
I think I missed how you said it gets deleted. Does it just...
When it goes out of scope. So it's again, the analogy is the string class. Let's take a step back and talk about the string class, which is all the string class is a wrapper around C-style character arrays. And managing strings in the C language is a huge hassle because if you allocate 5 bytes for Todd, T-O-D-D, and then a 5th byte for the null termination, and then I want to make the string larger and have my full name, Todd Gibson, the way to do it is you have to dynamically allocate enough space for Todd Gibson. You copy the Todd down, and then you copy the Gibson after it, right? And then if we want to add more to it, you have to go through the same process, create an even larger array of characters, copy the existing stuff, and append to it. And plus releasing the one that we just copied from. So there's a lot of dynamic memory management for managing arrays of characters. That's all the string class is doing. I shouldn't say all because it's fantastic. You don't have to worry about any of that. You can do simple things like saying str plus equals Gibson, and under the hood it's actually allocating more memory and copying over and releasing the old memory. All right? So suffice to say, every string, at least every string or over, say, about 15 characters, has memory that's been dynamically allocated, and when the string destructor runs, it releases that memory. And you don't need to know any of that because you're not, since you're not creating string pointers and you're just creating strings, they automatically get released at the nearest closed curly brace. The enclosing block, the end of the enclosing block, I guess would be the right way to say it. Likewise, this thing is like a string in that once it hits the end of the block, it's going to run its destructor, which will in turn delete the memory, which calls maps destructor.
But if it runs into an exit before
Exit will call all the destructors.
it does as well.
Yes. All right, so there's the making of the pointer. So you'll note that what I've done is the creation of the map object has just been put in this try block, which means 99% of the time it's going to be fine. This will run without a hitch, and you'll immediately hit this line of code beyond the end of the sample here, right? Because this curly brace, which is the start of the catch block, correspond here. You know what I need to do? I need to just copy this so we can look at some syntax coloring. What do I want to call this? Map init. How about map object init.cpp. All right. So if I space these curly braces a little more traditionally, it might be easier to see. There you go. So this is the begin catch, and then here's the end catch. So here life goes on. So 99% of the time, this will run without error, and the next line of code to run will be, excuse me, line 20. It's only when this throws an exception in the creation that then you immediately fall into the catch block, and this will print out what the error is. If you crack open map.cpp, you could actually track down the throw, and you would see the text that it is initializing that with. So it'll print whatever that is, and then here is bitboard is my shared memory. And remember, that is now not just simply an array of bytes, but has that structure at the end of which is that array of bytes. And one of those was a character representing the players, and we used that to flip bits to determine which players are currently playing. What I do is I made it so it would work either way. I'm assuming that maybe you threw the bit out there, but this works great if you haven't flipped the bit yet. So it doesn't matter which player you are, but if you had set player ID to G_PLR0, then what it does is it turns all the bits on except for that one. So basically it's turning that bit off, and it's just an examination to see are there no players on the board if you remove the player who just threw the exception. If you haven't set the player ID bit yet, then just do that. Anyway, if there are no players on the board, the reason you're asking the question in the first place is you want to close shared memory, remove it, close the semaphore, and remove it. Right? This is good cleanup. If you throw an exception because the map's too far, clean up any of this stuff that you may have put out there. Yes?
This is a little silly, I guess, but I was error calls on the system stuff, and I ran into the issue of like, should we be checking if send close errors out? Because I feel
No.
like we should just-
So the rationale you want to use is the same for healthy C++ design. The analogy is in a destructor of a class, you never, ever, ever want to throw an exception. So I would say this is analogous to a destructor, right? You're destructing, removing, closing down. Don't just do it and end. Don't make it more complex because you don't want to have to error check your cleanup code. And then if you threw an exception, then you'd go ahead after cleaning up the shared memory, you'd go ahead and exit. So that's the reason for the exception handling, is to be sure and clean up your shared memory and semaphore if you're the only player at the time. So that's what all that is. If you, I think did I say that twice? No, I did. All right, I need to go in and correct. I need to remove one of these. These are redundant. So that's a text file. If you have an error in opening the shared memory, you should only have opened this if you had done a sum wait on a semaphore. So close the semaphore. If you were the first player, you want to remove the semaphore. And then you exit. And that takes us to truncate. You want to remove the semaphore, remove the shared memory, mmap, close the semaphore, close the shared memory. If you're the only player or the first player, this would be, all this stuff is in those, remember I said you had two functions depending on whether you added the map and you're the first player, or you didn't add the map and you're not the first player. So you know which function you're in, so you'll know whether or not you need to remove the semaphore or shared memory, so you'll know whether you're the first player. Obviously, if you're the third player, you don't want to remove the semaphore and the shared memory and ruin the fun for everyone else. I'd like you to make sure you're checking the text file. That I think it's fine for you to assume that the first thing's an integer, but I'm mostly concerned with the map itself. Spaces, new line at the end of the line, and asterisks. And that code isn't as complex as it sounds. Switch the character, case, space, 0 byte to shared memory, break, case asterisk, gwall, byte to shared memory, all this depends how you're reading it in. Assume processing a line. So this would have gobbled up new line at end of line, so I don't have to worry about new lines in this case. So that leaves me with default.
So in that, you're still doing, you're reading the line and then you're looking through each character in that string. That's what you're talking about here.
Yeah, so I probably have something like for char ch in line, this is for string str, let me see, string line in my map string vector. I think it looks something like that. So, illegal character in map text file, that's just simply a matter of bailing out, cleaning up and bailing out in your default case. Let me see. So this is error handling for, I'm not going to say number 10 since I have to tweak the numbers and remove that redundant one. So let me say that. And then the only other one that make sure to handle is that if there are no player bits available, you have to complain there are already 5 players playing. Be sure to close the shared memory, and the semaphore, you're obviously not going to remove them because there are 5 other players using them. Okay. So if you're already done with the project, then this will let you make your code robust and cleaned up. And if you are one of the folks, and you're in good company, I know many of you straggled in late. I'll just say it again for the record that a third of you didn't turn in anything, and that's a surefire way of failing the class since you need to use Project 1 and Project 2. This is your chance to get another week to pull it together. What I'm going to do to encourage you to work diligently is I will take questions to the extent there are today, and cut you loose. And then on Thursday, I want everyone to spend a few minutes with me showing me what you got or what you don't got. And that isn't for, I'm not going to point and laugh or anything. I might laugh a little bit. But just some accountability, right, to get you to do something. I mean, if all you got is a hello world, then show me a hello world. Show me something. Okay? 2, 4, 6, 8, 10, 12, 14. We're missing one person. All right. That one person, I assume, will get it on the screencast. So, let me make a little bit of a comment about Project 2. What you're going to do is you're going to take Project 1. Let's say you do a make clean, you clean out all the object files and executables, and you've got this code base in a directory that you bundle up and submit as Project 1. Whatever I unbundle is going to be important for you to preserve, and let me say what I mean by that. Project 2 is you're going to want to copy that code. So if you have it in this directory, make an exact copy in another directory over here. Do all your Project 2 stuff here. And then I'm going to introduce you to another technique for the way you submit this is you're going to generate a patch file. And what a patch file is going to do is it's going to take all the differences between what you turned in for Project 1 and what you're turning in for Project 2. So you don't bundle up this directory. What you do is you submit a patch file. And what I will do is I'll take your Project 1, I'll run your patch on it, and that'll give me Project 2. Okay? So it's very important that your starting point for Project 2 is what you have handed in for Project 1. All right? Yes?
The patch file, source code file.
It is a source code file. So you all are familiar with diff, and you just run a diff and it shows you, yeah, you may have done vim diff. You've certainly seen if you use Tyson's turn-in tool, when you turn in a lab, it shows you 2 panes. That's actually running, that's running vim diff, and what vim diff is running is it's running the diff utility, which shows differences between 2 different files. So the patch utility basically runs diffs on all the files and automates the process of me just taking some original directory, running this patch file, and it diffs out everything. And it also handles things like deleted files and new files. Any other questions?
Yeah, you have some recommendations on debugging. Something about that, but
Yeah, so
TDD or anything like that? I was having a hard time getting
Yeah, I guess you could use GDB. It gets a little more complex when you have that screen interfering with you, right, when it paints the map up there. Now, I have to confess I would have to dig around because I don't remember how you would redirect that output to a different terminal and have the debugger in a separate area, although I'm sure you can do it. So in the absence of having that information handy, I'll give you the Todd Gibson way of debugging, which is, and I did allude to this, and I directed a couple people to it, was this named pipe. So let me find my code here. All right. So I think I'm going to make this a little smaller. And I'm going to get rid of this one, I guess. So, yes. So it's the named pipe, or the FIFO if you want to call it that. And what I would do is I would I'd make FIFO. Now here's the thing. I'm on my Mac, and I'm using that Vagrant tool that I invited you to take advantage of. FIFOs are managed by the kernel, so you can't do them across a directory that's mounted onto it from a different system, which means that right now I am sitting on a directory that my Mac controls, even though I'm inside a virtual machine. Now, all's not lost. You just have to, since I'm running the code in my virtual machine, I just have to ensure that the FIFO is on a file system that my virtual machine controls. And so that the home directory of Vagrant's the obvious place for that. So you do something like make FIFO up in the home directory, whatever you want to call it, debugging. I can take a quick look. There it is. And then when I run the code, gold chase, I will make sure that all of my errors, all of my I am here 1, I am here 2, this is the value of this variable, all of that is printed out to standard error. So either using C error, or if you want to use a system right, then writing the file descriptor too. Probably C error is what you'd use. And then so you just have to say 2 greater than, no spaces between them, 2 greater than, and then you just give the name of your named pipe. Now note that it's not doing anything, and the reason is that something has to open up and read from that pipe. So you just come to a different terminal and you go ahead and cat, and there you go. So that, obviously, if I'd done that without the named pipe, I mean, then I get it right there. So what's the point? The point is that if I got past this particular error, and let me get past this particular error, I'm going to cat, that at this point, the error output just isn't going to work. Now, some of you may have tried that, and you get this weird step staircasing of error messages, and they wrap around, and the whole thing's just a mess. And if you're trying to print out a lot of information and figure out where you are and the value of variables and so forth, you need to switch to this method. Get another terminal going, or if you're using tmux, another pane going, and in one of them, just cat that named pipe, and then this one over here, just to show it, is the 2 greater than, which redirects to that named pipe. Okay, and So one of the complexities about Project 2 is that you're going to have multiple processes. They're all going to be talking to each other, and there is no output to see. And so you need to be doing this kind of stuff all over the place. So this is a good place to kind of get used to it to the extent you need to do some debugging. The next thing is you've got to build this stuff in small parts. I think there's an aversion. Well, let me back up. When I rewrote this, one of the first things I did is I wrote a little sample program to read in that map into a vector. And then I wrote a little routine to rifle through each of the characters of each string in that vector to make sure that I got that. And it was only after I had all that that I plugged it into the bigger application. And then the semaphores, right? I wrote a little sample program to see that I can create a semaphore, I can do a sem wait, and then I can do a sem post and a close, and then I can do an unlink. And I made sure I had all that semaphore code working before I started picking it and pasting it into the bigger application. You've got to write a bunch of small tests. I mean, I've been doing this since, when was my first formal programming job? 1990, 1991. I've been doing it a while, and I'm still writing stupid little test programs, even though I've done it a million times before, because I've been bit enough times by writing 500 lines of code and then trying to compile and wasting 3 days when I could have been much faster writing the test programs. So please get in the habit of writing the test programs. And I started to say there's an aversion to doing that because there's a thought that I don't have time to write all these extra programs. I got to get this project done, right? And then you throw all this crap in the project and shake it up and hope for the best. Looks like my drawer in the kitchen where that damn spatula won't let you open it. So yeah, if you are not 100% sure what that code should be doing, you need to write a test program. Learn how it works. Create errors. As soon as you add the code to clean things up when the map file doesn't exist, then the next thing you should do after you compile is gold chase, no such map. Confirm that it's there, and then you do an ls on dev shm, and you confirm that everything's cleaned up and you don't have shared memory or a semaphore sitting there. All right? Then move on. All right. So I'll go ahead and stop here. We obviously have half an hour or so of class left. If you have stuff you want to show me or for me to look at, I'm happy to do that. You're welcome to walk out of the room, but definitely come on Thursday prepared to show me something. Okay? All right.